Thank you everyone for tuning in today, and I hope you're having a nice JCon. So today we will have a conversation about race conditions and how they manifest, or things we can see in controllers, and especially Spring Boot controllers during this presentation. And then we will see a few ways to how we can mitigate the risk or some changes we can do in order to avoid that to happen. So during this talk today, I will try to have a look at the chat. If you have a question, I will stop from time to time to answer your questions. And at the end, I will leave some time at the end in order to have other questions in case some may arise. So during the talk, I have a link to Mentimeter. I will be glad if you want to join and enter your answer. There are just quick questions just to set the pace for this talk. So let's start. As I said, this is the survey. If you want to have a look and enter your answer, we will see. Okay, that's good. So I think we can go quicker. Thank you. So who am I? I am Giuseppe Trovato. I am a security researcher currently working at Veracode. Before being at Veracode, I had some time working as a pen tester, doing ethical hacking. And I was an application security consultant and doing reviews of many companies' code to find vulnerabilities and maybe help them fixing it. And before my current job at Veracode, I worked at an Italian bank for several years as an application security manager. And before that, I was developing application in Java.NET and PHP and some other languages. So let's see if we've got other questions, but it seems we are there. Okay, good. So let's start. So the agenda today will be to have a little bit of intro into race conditions to see what they are, how they manifest, how they are reported in the security space, and some real-world implications that happened in the past history and how they made history in some cases. Then after that, I will have a live demo of a very simple basket application. Don't expect too much. But the point of this application is just to demonstrate the vulnerability and hopefully see how that works. And then, as I mentioned at the end, we run the race in the sense we will use a tool to do a kind of load test of our application to see what is the output. So then few mitigation and test and to see how this mitigation work. Still using the same tool we will use to do our demonstration. And then at the end, a few conclusions and the question and answer section. So what are race conditions? A few of you said that you know what a race condition is, and a race condition is basically a vulnerability that happens when your system is designed to handle different tasks in a specific order, but if something happened that change or influence that order, this can generate few problems into your application that are often difficult to debug or even replicate. One can think that race conditions are a thing of the past, or probably something we heard only during our programming course in C or C++. I know that many of you may have not even used C or C++ or in their career, but this is even better now to be here and understand that race conditions can happen even in other languages and even more modern languages. So as I was saying, a race condition happens when there is two processes or threads that access the same shared variable. This means that the variable can be accessed in a different moment in different ways, maybe to read and write at the same time. And this can cause few problem at your application. So, and the problem with race conditions is that they are difficult to debug. And this happens because their execution is asynchronous, and they always happen when your application deals with asynchronous behavior. And many times their occurrence depends on the resources available at the time when the issue happens. So if your application, while you are testing it or when you try to reproduce it, is not under a heavy load, you may not even see your race condition, but that may happen later when your application is under heavy load. And this is something we will try to replicate later. So a little bit of history. I mentioned 3 cases that may bring to mind what a race condition can be. Terac 25 is a case that made history. It's basically interesting to read this story. It's among the most famous bugs in history. And it was caused by a low-level application reading the same variable to decide when this machine had to beam a magnetic field. And at the same time, the same variable was used to read the keyboard when to start sending this magnetic field. Unfortunately, this had very unfortunate consequences, killing few people. And the issue mainly was a race condition when the operator was typing too quickly. So another case that I think is interesting, and probably many people among the audience that tried it, is vending machines. When you push 2 buttons at the same time, you probably often hope that you can get 2 cans of cola paying only 1. And when that happened, and this happened in many vending machines in the past, that is because of a race condition. And another example more closer to the current world of web applications is a case of when you may be able to redeem multiple coupons on the same website just by sending many coupons at the same time, hoping that the application is not quick enough to realize that that coupon was already used. And this is the trick we will use later. So race conditions, when you look at them from the perspective of security, may have different names. And you may have heard them being mentioned in different ways, apart from race condition only. One is the talk to. Talk to is the acronym of time of check to time of use. That means when you have a variable that you read to decide if your application can do an action, and then performing that action. If the time between the read and the action is too long or is not protected by a critical section, what may happen is that the status that make you decide to continue may have changed. So, and this is still happening in modern sensors or critical environment where the order of execution is critical. Another area is session puzzling, and that is very much related to web application, or in general, any application that handles a session and use the information stored in the session to perform actions. Session puzzling is what OWASP, I think many of you have heard of this acronym, is one way they refer to race condition related to session handling. And then, why not to mention the scariest word I heard during one of my early computer programming course, that is deadlock, when you know that because of the order of execution, your application may be stuck forever because your application is reading the value, is expecting a value that was changed before it was expected to be changing. So, and talking about security and how this can manifest, a company called Mitre that I mentioned in this slide tries to enumerate weaknesses and giving them a number. So there are several weaknesses that received the number because of a race condition, and some of them are listed here. And I try to match some of them with the history from the list I made on the left. If you want, you can go on the Mitro website and search for them, and you may find a few details on what they are and how they manifest, or even how to remediate them or how to avoid them. So, coupons, anyone? We were talking about coupons earlier on. Let's see what we can do with a coupon. So this is the simple web application I made. It's very simple. You will see the code at the back. And that's basically what it does is already is preset, but you can enter a coupon. And the coupon gives you a discount. And you are supposed to use only one coupon. So I registered this domain. I thought it was fun. Let's see if it works. Yeah, it works, but on the wrong screen. Let's try to bring it here. Okay. This is our shopping cart. I hope you can still see it. Okay. So let me bring it back. Okay, here we are. So I'll stop for a moment. There is a question in the chat. Thank you, Christoph, for your question. So how to convince others they have possible talk to race conditioning code? Is the massive load and wait to fail the only way? So there are some approach you can do depending on what type of access you have to this application. So if you have what is called a white box access, it means you have the source code. You may try to write some model on paper or to model the application and show that timing can be an issue in their application, maybe with the old UML approach. Another way is trying to simulate it, as you were suggesting, that massive load and wait to fail the only way. That could be another way. You can try to demonstrate that if you load the application, something may happen. Remember that, notice that talk to is not directly related to load, but mainly to the frequency of one of the two activities, the checking and the action, and how they interlace between them. So it's often difficult to prove to somebody who thinks their application is strong that they may have vulnerabilities. But then if you can rely on some model to show on paper how it works, that may help. So can you see this small web application on the screen? Anyone can say anything in the chat? Oh, great. Thank you. So what the application does, reads the coupon and then returns with a real, very small REST service, the updated total. Let's try with a random coupon. Okay, you can expect this not to work. In fact, it doesn't work. Okay, good. So let's try with the working one, that is this one. So let's see. Yes. So he updated the code to 40. So let's look at the code now. So let me go back to our sharing. Okay, here we are. So this is the code at the back. We will see the application live in a moment. So what's happening? This is a very simple controller. We have a REST controller that this is the method of our controller that receives a value, our coupon. It knows that the basket total is this one, checks that the coupon is valid, and then subtract the value of the coupon from the total, and then return the total. Anyone sees a problem here or? So given what's happening here, so we start from 58.93, then we subtract the coupon, and then we return the value. What we think can be the value of our basket if we can exploit a race condition here. Let's try and see that in a Mentimeter survey. So same survey as before. Don't be shy. So let's go to the next one. So how much should we expect to pay? So 58.93 is the original basket, and then we remove 18.93 from the coupon. And then we have a few options there. Let's see. Okay. Show results. All right. Yeah, let's see if that's true. So it's 40 when everything goes right, but it may be that if two threads access the same method at the same time, we can get 21.87. That means we subtracted our coupons twice. But in reality, we can get anything below 40 because our coupon can be subtracted even multiple times. And if you're lucky, saying you consider yourself lucky, if you can apply the coupon multiple times, you may even get a negative value. So let's see why it does happen, and then we continue. So this is our code before. Let's assume we have two threads at the same time accessing this web application. So in a normal way, in a normal configuration, Spring controller is accessed with multiple threads accessing at the same time. So the problem are these shared variables, but we have only one variable that is modified at runtime. The other are just only read. So what happens is that we have two threads, both read the same value, 58.93. But given they are executed at the same time, one may be a little bit ahead compared to the other. So both read the same values. And then what happens is that maybe the thread number one continues. So, and what it does, it goes to the subtraction. So it removes the value from the coupon and returns 40. Then thread two restart. So, but now the basket total is no more 58.93, it's just 40. So now it subtracts the coupon again. So it returns 21.07. So this is one simple case of what can happen. So now let's go to the real demo. Let's run this race I mentioned. So I will be using few tools today. One is Burp Suite. I think many of you may have heard of it because it's often used as a test tool to test application, or maybe doing few white box or black box testing. Many pen testers use it. So, and it's basically a suite of security tools together with a proxy tool that many pen testers use. And Burp allows you to add other plugins. And the one we will be using is called Turbo Intruder. So it allows us to send a large number of HTTP requests in a specific way. And then you can program it in a way that you can decide what your intruder will do and when to send all the requests. I will give you a very quick introduction to it in a moment. So let's give it a go. So this is Burp. I have already configured it, and I am using a local instance of this infamous basket. And we can see here that Burp shows us what is being captured from this application. This browser is using Burp as a proxy. So quickly, I'll show you, you can intercept calls. And let's do it now with another time, a wrong coupon. Okay, so anyway. So what happens is that Burp stops and shows us that this is what we are sending, the HTTP version we are using to what host we are sending our request, and a few other details of this request. We forward it and we will see what the server returns. So the server agreed, so that is a wrong coupon, it just returns 58.93. Let's try once more, and then we start from there. So this is the right coupon. So when we send it, again, we are sending the right coupon now. What we get back is 40. So it looks like 40 seems to be the right number. So let's continue now. So let's go and use the tool I mentioned, the turbo intruder. So what I'm doing now, I'm just selecting the payload we will be using, just because in this example, we will be using the same payload because we want to retry the same coupon multiple times. So what we do, we trigger the turbo intruder, and here we are. So what you can see here, this is the request that we sent before earlier. We are just resending it again. We have it here, and this is a placeholder that will be used to pass our payload. That in our case is the same payload, is the base input that we selected when we entered here. So what happened next is we set the engine. It's fun because it fits with the race discussion. And then it starts queuing requests all together and start sending them and hold until the very last byte. So then when we open the gate, all the requests are sent at once. So this will create a huge load in the application, and being a local server on my machine, it's easier to load it. So and then what happens, what I made here, this is an annotation that tells to filter all the requests that contains 40. So the responses. So the responses returning 40 are correct responses. So responses that is when the controller executed in the way we expect. All the deviation from 40s are issues that were introduced because of our race condition. So hopefully we won't see any 40, but we will see other numbers. Let's see. So when I click attack, you see that the engine will warm up and send the request. So let's see. Okay. So we sent 300 requests, and out of these 300, we got 4 responses with a different value than 40. So, and the server returned 2107. This one is 4893. Another issue that may happen with race condition, it may be that you reset the value that you already changed. So you end up with the same value as before. So 2147, we can execute another time. Let's see what happens. Let's run it again. Okay, this time we were less lucky. I've tried this a few times. In some cases, I was also able to get to a negative number because the coupon was subtracted multiple times. So let's try once more, and then, okay, only one. I think that's enough. We got the gist of it. So what I will be doing now is I will show you this controller on my web application and different version using small changes. And then we test these changes again with this tool so that we can see if the change had an impact. So as we saw, this is kind of reliable way of checking that we have a race condition, at least in this small environment that is my local machine. So let's go back to presentation here. So we did the request interception, we checked the response, we passed an invalid coupon, a valid coupon, and then we had this brief chat about burp and the turbo intruder plugin. So let's continue. So these are the mitigation we will be discussing later. So let's go to the code and we'll see. So this is the basket controller I mentioned. It's the same code as I displayed before. So, and the issue we have, as I said, is this variable. So in a way, we should protect access to this variable. In order to create, we might have option. The generic idea is to create a critical section around this variable. That means that we stop multiple threads accessing the same variable when there is a thread who is already dealing with this variable. And we have few alternatives in Spring that we can use. And let's see one. So let's start one way, checking few. I will be making this application available online so that you can play with it or do changes. So you will be able to find it on my GitHub. So here are a few versions of the same basket with few changes. So let's talk about some of the options we have. So I was talking about critical section. A way we can do, we can create a critical section is by using reentrant. That is available from Java 1.5. So, and what it makes, it handles internally a semaphore based on synchronized. So it used the synchronized keyword to access a mutex, a mutual exclusion framework, a semaphore, to protect access to this variable. And this is what it does. So what I did, I added this reentrant lock inside my try catch. I'll tell you why try catch is not a real try catch, is a try finally. I'll tell you why this is useful. So we are locking our semaphore, accessing our variable, doing whatever we wanted, and then return our updated basket total. And the finally close will be taking care of releasing this mutual exclusion, this mutex. And this is important, otherwise no other thread will be able to access the same section because it will stay locked. This unlock here allows us to perform the unlock after calling return. So if we will be moving this after return, it won't be executed. So let's give it a try and see. So this controller, modified controller, is accessible to reentrant basket. So just we will modify the previous load test with this updated basket, and we will see. So let's go back to our tool. So now we will be sending our request to this updated basket. It's the same basket with this reentrant condition. Let's run it. Let's see. So it's completed. So no value different than 40 was received. Let's try another few times. From time to time, you may see a null return, but that is when the request return went on timeout. That is not a race condition. It's just that request was too slow to come back. So nothing happened. So it seems that our critical sections is protecting us. So let's try another variation of the same approach. I'll show you a few, and then maybe you tell me if you want to test one in particular, or if that's enough, so that we can go, we can continue. So another approach can be to use a semaphore. In this way, you will be handling the critical condition yourself. The principle is very similar to the reentrant lock, but in this case, you are dealing with the semaphore yourself that has the mutex variable inside it. So same as before. And here we have, again, a finally close that helps us releasing the lock once we are done with it. So I can assure you this is the same as before. So we can skip and go on. So another approach is to use synchronized. So synchronized is applied on a method. So that means that access to this method is protected by being synchronized. Only one thread can access it. So in our scenario, it may not be good enough to have synchronized only on one method, because our variable in a real world situation may be accessed elsewhere. So we need to change this approach and maybe making a getter or setter being synchronized on that variable. So let's go to another case that is, I think, is interesting. So one case is to using the scope annotation. The scope annotation allows, and this is available in web context, in the web space in Spring Boot, for example. The previous cases, the lock reentrant, semaphore, or synchronize are available in any bean context, because these contexts are available inside the application context. These contexts are available in the web context because they rely on specific beans or information in the application to decide when to give access or block access to the resource we are flagging. So in this case, we say we want to scope the full controller to the application. This means that the whole application will be sharing this object. So this is not of much help in our case, but we can try. So we have our tool here. We try it again, and now we are testing it against the controller version that is application scoped. So let's see if this works. As expected, it returned something also. There's very interesting value. I still need to understand what's happening here, but I've seen this few times, and this is the case when I think there is some weird access to the same variable, and maybe the variable the value that is saved is written half in half. I will investigate a little bit more maybe in future. So scope application in our case doesn't work. I will mention later on in the last few slides why it doesn't work. So this is, okay, the scope prototype is another scope available in the bean space, but it's of not much help. It has the same issues than an application scoped controller. So what I want to show you is, and this will be interesting at the end, is that you can also tie your controller or your bean to the request. So it means that every request will get a separate version of the same instance of the object. So it's a different instance. So in this case, we are just, the whole code is the same. We are just adding this annotation on top. So this basket controller is accessible to this endpoint. Let's try it. Let's see. So we attack it. Yeah, so no issues. Okay, that's good. So these are the other options that are available. One word of caution that I will summarize in a few minutes is that annotation, the scope annotation, can be applied at an instance level or at a method level. So, but they have a slight different behavior. So you must be careful when you apply your scope annotation, because that changes what happens. So I'll show you in a moment. Let's see. So we saw that the scope request annotation works in our context. Now let me try with this annotated method. I have annotated enter coupon with the same annotation. So as you see, the controller is no more annotated, but the method is annotated. Let's try it. Let's see what's the difference. So we are accessing the request method basket, the controller method that is annotated. So yeah, so it's not protecting us. The reason being that when you use the scope annotation at an instance level, the whole instance is under the same scope. But when you annotate a method, only the object returned from that method is in that scope. So it means that if we use the scope request annotation in a method, only the return value of the method will be, the return value will be instantiated once per request. but that is of no help to us because the return value is just a double, and the double contains already the value that is modified by the race condition. So the problem is earlier, so it's not the right way to fix it. So these are a few examples. So basically, you can see that you can deal with this critical section yourself, dealing with your semaphore or locks, and decide what you want to protect, or you can use this scope annotation so that you can protect your controller or your methods, depending on what your application does. Be wary that what have an impact is maybe performance. So depending, usually it's suggested to keep your critical sections to the minimum, to just protect the variables that are important to your application. So it may be that the scope annotation may not be the right solution for you in terms of performance, but it's not always said. And another word of caution is that if you are not seeing a race condition result in a specific case, for example, if you're not seeing your application, even though you know there is a race condition, reporting any unexpected value, there are several reasons why that may happen. As I mentioned before, maybe the load is not too heavy. And another thing could be that you may not have the web server you are using is calling your controllers, assigning a thread per controller so that you don't have controllers shared between requests, for example. So I've seen this with other languages, for example, with, I think in PHP and the Nginx web server, the Nginx web server allocates one instance per call and per request. So even if your code is vulnerable, it may not be vulnerable when you run it in a specific web server. Oh, thank you, Matthias. Oh, good. You did the math. Great. Amazing. Yeah. Thank you. So let's go on and finish our few slides, remaining slides. So the mitigations or remediation, depending if you're able to fix it, I hope you can, are several. First thing, avoid storing shared variables in member fields in controller and servlets. That's always not a good thing. I wouldn't advise you to do that, especially if you have read-write access to it. If you are only reading it and the value is not modified, that's not a big issue. For example, if you have your logger class, or if you have your entity framework access or something like that, that's fine if you're just using it as a reference to your object. In J2E, and then you will find this even in the MITRE list, it's very bad practice to implement thread management yourself in a web application. Let's leave your framework do that for you. And then, as I mentioned, and this is just a recap, you can manually handle the critical section with a few techniques I suggested. So, as always, when you manage lock a semaphore, be wary of deadlocks. Remember to lock it in the right order, especially if you have different number of readers and writers. So let's go on. So there are, as I said, other annotations that are available at level scope of a bean. In our case, singleton didn't work. If we use prototype, it worked because there is a different instance for every invocation of that bean. Then if you have a web space or a web application, you have different contexts that you can use. In our case, the scope application didn't work because the controller bean is shared among all the requests in the servlet context. So, and this is the word of caution I mentioned. Be wary of the difference between annotating at type level than to method level. And this is a reference to the documentation. So if you want to have a read. So thank you very much. I think I stayed right in time. Do you have any question? Is there anything you want to know about what I do, or? Okay, yeah, questions are coming. Okay, thank you. Yeah, good point, Andreas. Yes, yeah, that's good. Yeah, so that is the best approach. Yeah, you try to avoid the controller to be your, say, your entity, because that the controller is multi-threaded. So that is the issue. Yeah, okay. I see, Christoph. I'll show you. I have a similar example. If you want, you can ping me. I can show you other examples I've made. But then, for example, this is similar. So in this case, I'll give you a quick refresh. So what's happening here, rather than using only the value from the request I caught or I stopped before, I can send two different requests. So for example, let me do this quick change here. So we will have a set of requests created on the original request with my payload. That is what was selected. And then here we will be sending this request to a different payload. And then you decide when to release them. So this is what you can model what you want to send to the controller or to your web application. So you can say, send this packet of information only if this condition happens. So you can model this in this way, what you send, and you can see the results based on your label. So you can assign a label so that you see what request caused that trouble in the response, for example. Okay, another question from Martin. Thank you, Martin. So I know that app is yeah, Martin, you have a good point. Yeah, that yeah, it's better not to make things synchronized, because that is a waste of CPU and time and resources on your machine just to deal with a single variable. Yeah, that's a good point. Thank you, Rume. I'm glad you liked it. Thank you very much. If there are other questions, here are my details. Feel free to ping me or email me. I would be happy to interact with you. Oh, sorry. Hey, here it is. I'm glad that you liked it. And let me know if there is anything in this. The GitHub is still private. I will be doing a few changes, and I will be uploading this presentation in the JCon folder and also in the GitHub. So you may find it there.